Hey everybody, so we're going to talk about similar triangles today. These notes are missing a few things, so if you bear with me, I'm going to get some stuff drawn on here. And so basically to start with, we need these two triangles. We're going to have this triangle here. We're going to call this triangle Triangle Cat. And we've got this triangle here. And we're going to call this triangle Triangle DOG. Okay? So, if we are given the following things, if we are told that angle C is congruent to angle D, and angle A is congruent to angle O, is that enough to say these two triangles are congruent? Well, if you think back, if you can remember this far back, to our discussion on congruent triangles, one of the ones that didn't work was angle, angle, angle. What we figured out, though, is that all the triangles there were similar. They were all looked the same, just they were bigger and smaller versions of each other. So here, if we know that angle C is the same as angle D, and we know angle A is the same as angle O, well, the third angle has to be the same too, because all triangles add up to be 180. So if we knew that, say, this was 100, then this also has to be 100, because they're the same. It says so right there. And if we figured out that this was, say, I don't know, 30, then this one would also have to be 30, because it says right there they're the same. And so then if we do the math, we find out that this one has to be 50 and this one has to be 50. Okay, so these are similar, and the reason they're similar is because two of the angles are the same. If two of the angles are congruent, we can say that they are similar, which brings us to our first postulate. This is called the angle-angle similarity postulate. Okay? So, and it says that if two angles of another, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So let's draw that picture again, or one similar to it. If we had a picture something like this, CAT, and we had a bigger one this time, make the dog bigger this time, of DOG. If this angle here says angle C is congruent to angle D and angle A is congruent to angle O, then we can say that triangle, remember you can name the first triangle however you want to. I'm not going to name it cat and dog this time just to show you. I'm going to name it ATC is similar to triangle. Oops, barely see that, can you? It's going to be triangle. Since I did A had the two arcs, that's going to be O. I said ATC, so the no arc and then the one arc, so that would be G and then D. O, G, D. Okay, that's the angle-angle postulate. If you know two angles are the same, then you know the triangles have to be similar. Okay. The next postulate is the side-angle-side similarity postulate, theorem, excuse me. Don't worry about the difference. Actually, I believe that should be postulate, but in any case, not a big deal. If an angle of one triangle is congruent to the angle of a second triangle, and the sides that include the two angles are proportional, then the triangles are similar. All right, so let's take this picture. Let's take BOY and triangle MAN. All right, so it says up here that BO, this one, is proportional with MA, okay? Or it's set up in a ratio of BO to MA. And it says that angle O is the same as angle A. Well, for this to work, for it to be side, angle, side, it has to be side, the angle, and the other side that is making this angle, which would be this one. So this one, I'm putting two little marks on that way. would have to be in a ratio with this one. So since I did BO first, BO over MA, I have to do OY over AN. Okay, because you did BO first on top, so you got to do OY on top. And so if these things happen, if BO over MA equals the same amount that OY over AN does, and these two angles are congruent, then triangle OBY is going to be similar to triangle. Okay, I did O, which is the one arc. That'll be the A, the one arc. O goes to B, which is down the side with one dash on it, so it's going to be A to M, A, M, N. Okay, and so the same thing down here, but with numbers. If we said that, if we said that angle B is congruent to angle M, if we were given that, and then we were told that this is 4, and this is 3, and this is 8, and this is 6. Okay, so here's how that would work. Actually, I want to change that. Bear with me, I'm sorry. Make that 6 and that 8. Here's the thing. Angle B does go with angle M, but I've changed this up. It's not going to be the same answer that we got up here. Now, the question is, where does 4 go with? Does 4 go with the 6 or does 4 go with the 8? And in this situation, the 4 would have to go with the 8. And the reason why is the biggest number on this one would have to go with the biggest number on this one. You got to remember that triangles can be flipped, rotated, whatever. So in this case, 4, I'm going to get one dash on it, goes with 8. And then 3, 2 dashes on it, would have to go with 6. And the question is that equal? And if you put these in the calculator, you get 0.5 and 0.5, so absolutely they're equal. So they are proportional. And if they're proportional, if these two sides are proportional and these two angles are congruent, then these are similar because of side-angle-side similarity. Now the statement, though, triangle BOY would be similar to triangle. Now B does go with M. Angle B goes with angle M, but since it goes, we did BO, B to O, the one with one dash on it, I'm going to have to go M to N and then to A. It's going to be M, N, A on that one. All right, there's one more that we need to look at, and that is the side-side-side postulate. And again, if the corresponding sides of two triangles are proportional, then the triangles are similar. So, in the following triangle, okay, we're going to make an ear joke this time. So, in these two triangles here, we've got EAR and LOB. All right, so since EA goes with LO according to this, and AR, two dashes, goes with OB, well then ER, be the last one, would have to go with LB, right there. All right, and so we can then say that triangle EAR is similar to triangle LOB. Okay, because, by the way, that is the side-side-side similarity postulate. For this one, to give us actual numbers to work with, we've got 15, 39, 36, 5, 12, and 13. Okay, now remember, the smallest number goes with the smallest number. Okay, so if you look at this, 15 has to go with 5. 15 over 5. The biggest number goes with the biggest number, so 39 goes with 13. And then 36 goes with 12. And the question is, are these things all equal? Is this true? Can I say these things are equal? If you divide all these in the calculator, you find out that each one of them equals 3. Now, if you did it the other way, if you did 5 over 15 and 13 over 39 and 12 over 36, you get 1/3 for each of them, and that's fine too. So yes, these are by side, side, side similarity. That's how they are similar. Sorry, just realized you couldn't see that. All right, and so finally we have some examples. All right, so on this one, first thing I know is that this angle has to go with this angle, because those are vertical angles. Now I need to see if the sides are proportional. Well, remember, the shortest side goes with the shortest side, so 50 goes with 15. And then 60 would have to go with 18. All right, now, if I get my calculator out, 50 divided by 15 is 3.333333, and 60 divided by 18 is 3.333333. So those are equal, and if those are equal, then these two triangles, those sides are proportional. And if the sides are proportional and the angle in between them is congruent, then these are congruent by side, angle, side similarity. And so WVU would be the same or similar to W. Let's see, we go down the shorter side, so I'd go down the shorter side here, WMN. There we go. All right, as for this one, I only see sides marked, so if these are similar, it's going to be by side. So I'm going to have, let's see, the shortest side is 8. That will go with 48. I'm going to write that down here, 8 over 48. The biggest side is 10. That will go with 60. And then 9 has to go with 59. So the question is, are these things all similar? Well, let's see. 8 divided by 48 is 0.166666666. 10 divided by 60 is 0.1666666. 9 divided by 59 is not. So no, these are not similar. Okay. The next one also has just sides. So if this is going to be similar, it's going to be by side, side, side similarity. So on this one, I'm going to have, first of all, I need to separate these guys. I can't look at triangles combined like this. That's going to drive me crazy. So that's 24, that's 36, and that's 32. Okay. And I've got my bigger triangle here. That's 78. That's 104. And if I add those together, I get 117. So again, the smallest number goes with the smallest number. So 24 over 78. The next biggest goes with the next biggest. So 32 over 104. And 36 goes with 117. Are they equal? I don't know. Let's take a look. 24 divided by 78 is 0.30769, so on, whatever. 32 divided by 104 is the same thing. It says so. And then 36 divided by 117, they sure are. I could not tell that by looking at these. So yes, they are similar. Side, side, side similarity. And QRS, Q to R to S, would be the same as Q to D to C. Q, D, C. Or similar to, rather. Okay, so on this one, oh man, this one's super easy. Check it out. I've got this angle. It's mirrored to that angle because they're vertical. And I've got an 89 and 89. Yes, automatically. These are similar. Angle similarity says so. That's nice. I like those. So it starts LMN, so the vertical angle to 89 to the one that's not marked. So the next one would be LEF. Oops, sorry, triangle. Forgot to put my triangle there. And I forgot to put it all over here. Goodness gracious. That's going to be triangle LEF. All right, guys, I hope that helps. I'll talk about this stuff more in depth tomorrow.